أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. Assalamu alaikum, dear viewers. Today we'll be talking about some basic measurement in epidemiology. What is measurement in epidemiology? What are their different types? We will be discussing and explaining one by one. So let me share you the slide first, and then we will move ahead. So basic measurement in epidemiology, these are a few objectives: the concept of mortality and morbidity, the rates, ratio, incidence, and prevalence, maternal and infant rates in the specific community. So what is mortality? Mortality means death. Mortality is the term used for the number of people who died within a population. For example, if there is a specific community of 5,000 people and 10,000 people, and people die at a rate per month, per week, per year, usually it is counted as per year. Like in 2020, how many people died in that particular community? So that is the mortality rate then out of the total population. Mortality rate, a measure of the number of deaths in a given population. So we measure it through rate. What is the rate? What is the prevalence, and so on. So the rate, not basically the prevalence, but the rate, at what rate the death occurs. So that is measurement of number of deaths. Morbidity refers to the state of being diseased or unhealthy people within a population. Basically, it is the number of diseased people in a particular community. The extent of illness, injury, or disability in a defined population. This is another definition. And morbidity rate, similarly like mortality rate, we have to calculate the number of people who get the disease in a particular community. A measure of diseases in a given population, for example, prevalence rate and incidence rates, etc. So this prevalence rate and incidence rate are basically the measurement of the disease. Measurement of disease frequency. Summary measures. Public health questions are about population. So public health professionals or epidemiologists, they are mostly concerned about the population, not an individual. Information about population characteristic is often summarized in an index. Changes in population characteristic can be assessed by comparing summary measure. By comparing summary measure, mean the death rate, the morbidity rate of one population to another population. That is comparison of summary measures. Rates, ratio, and proportion. Three general classes of mathematical parameters often used to relate the number of cases of a disease. Numerator or health outcome to the health outcome is also the disease, to the size of the source population, the total population, from where these deaths are the numerator occur. So denominator in which they occur. Numerator has to be defined. There must be a clear-cut definition of case, that is numerator. And denominator, it must also be defined. What is the population out of which you are taking the cases? So these definitions are most important so that you can understand from where have you taken the case and what is the population size where these cases are numerator occur. Ratio of 10 by dividing one quantity by another quantity, a general definition. These quantities may be related or may be totally independent. Usually expressed as X divided by Y. Example, the number of stillbirths per 1,000 live births, number of stillbirths over number of live births. So the two quantities are quite different from each other. There are stillbirth and there are live births. So live births and stillbirths are different from each other. A ratio is a general term that includes rates and proportion. When to say a proportion is a ratio and when we say a rate is a ratio. There are specific definition. There is specific definition of rate where when you have to say a proportion is a rate and when you have to say that is not a rate. So it depends upon whether if the numerator is taken from the denominator, then according to the general definition, it is a rate. It is a rate and proportion, and as well as it is a ratio, according to the general definition. Because one quantity, although divided by another quantity, so the general definition of ratio is like this. But according to the specific definition of ratio, numerator is not taken from the denominator. For example, male versus female. Male ratio female. So male is not taken from the female. In that case, it is purely a ratio, a pure definition or specific definition of ratio. Ratio is a general term that includes rates and proportion. The value obtained by dividing one quantity by another quantity, a general definition. Examples of ratio: observed cases of AIDS in a country A in June, expected number of AIDS cases in country A during June. So 40 cases or 20 cases is equal to 2. There is no unit if the numerator and denominator having the same unit, both the units are then cross. Number of hospital over population size, R may be multiplied by K, a constant, 10,000, 1,000 and so on, hospital per 10,000 people. Suppose R is equal to 4 hospitals and people are 20,000 people, so 0.0002 hospital per person. So it doesn't make a sense. What you have to do, you have to multiply this with some certain constant so that you can take, you can obtain a value with whole number. So 2 per hospitals per 10,000 people. It means that for 10,000 people, there is a need of 2 hospitals. Hospitals per 10,000 people. Hospitals per 10,000 people. Proportion, a ratio in which the numerator is included in the denominator. The number of fetal deaths out of total number of births. Proportion, here also one quantity is divided by another quantity, but the numerator is taken from the denominator, and that's why you are dividing one quantity by another quantity, but that is not a ratio, that is a proportion. Number of fetal deaths over number of live births plus stillbirths into 100. These number of fetal deaths are taken from this denominator, stillbirths and live births. Answer often read as a person. A type of ratio in which the numerator is included in the denominator. So according to the general definition, when quantity is divided by another quantity, that is a ratio. But when you take the numerator from the denominator, so that ratio then is called a proportion. Properties of proportion. When can you say that it is a proportion? So there are certain properties of proportion. The number of individuals in a population, that is N, and X is the number of individuals in the same population possesses character C. So we have to put this in the formula. P proportion in the population with character C is equal to X upon N. This is basically the formula. Further taking it ahead, P takes values from 0 to 1. P is a fraction. From 0 to 1, it takes a value from 0 to 1. 1 means 100%, 0 means the absence, and nothing has happened, any death. And 0.1, and 0.2, 0.3, 0.4, 10%, 20%, 30%, if you multiply with 100. P has no units because the upper unit, the unit of numerator is cut with unit of denominator. These having both the same units. P may be multiplied by a constant where K is a number such as 100,000 and 10,000. So you may multiply it with any of these numbers. Proportionate mortality. In 1995, 53% of all deaths in Africa were children under age 5. So P is 0.5 or 53%, 53 per 100. Per 100. So 530 per 1,000. And if you multiply with 10,000, so that will give you per 10,000. Rate, a measure of how quickly something of interest happens. Example, the number of new cases of Parkinson's disease which develop per 1,000 persons years of follow. So here the numerator are the cases and the denominator are the persons years. How much time is spent by an individual? So you have to calculate all the add up all the individual time and put it in the denominator. Time, place, and population must be specified for each type of rate. In a rate, numerator may or may not be a subset of the denominator. Whenever it is taken from the denominator, year, time is necessary to be mentioned with, and only then it can be called as a rate. Rate may or may not be a proportion. It may be a proportion, it may not be a proportion. If the numerator is taken from the denominator, it may be a proportion. And if the year is mentioned or not mentioned, and if the numerator is not taken from the denominator, then it is not a proportion. Then it is a ratio. Properties of rates. The calendar time period is the same in both the numerator and denominator of a rate. A rate expresses the relative frequency of an event per unit time. Examples of rate in vital statistic. Infant mortality rate is the example of a rate, number of infant deaths per 1,000 live births during a calendar year. So numerator is not taken from the denominator. There are live births and there are deaths. The IMR is a ratio. The IMR is not a proportion because the numerator is not necessarily part of the denominator. Some infants may have been born during the previous calendar year. Prevalence, measure new cases of a disease that develop over a period of time. Very helpful for etiological and causal inferences, and difficult to estimate, implies follow-up over time, that is cohort design. Now, incidence is basically the new cases that occur with the passage of time. And that's why it is helpful for etiological causal inferences. The reason is you are spending time, you are making follow-up visits, and you know whether the factor is associated with the disease or not. So with the passage of time, you come to know that those people who are exposed, whether the disease develop or does not develop. So in that case, you know whether it is etiological, that factor is etiology of the disease, or that is a causation of the disease or not. And difficult to estimate because it is not fixed like prevalence. So it is difficult. There are many problems. Why it is difficult to estimate? Because there is whenever you take a sample, there is attrition problem. So people may refuse and so many things. So if you have a very decreased sample, so it is difficult to estimate. It implies how people follow up over time. Another difficult time, you have to make a follow-up visits, periodical visits after 2 months, after 3 months, and you have to see the sign and symptom in the sample that you have taken, and the people those who are exposed and those who are not exposed. Prevalence, measuring existing cases of a disease at a particular point in time or over a period of time. Prevalence is a fixed proportion of a fixed rate where whenever you visit a community or a population and how many people you have to determine the magnitude of the disease. For example, 100 out of 1,000 people are a disease. So that is a prevalence. It may be point prevalence. At one point in time, you are collecting the data, or period of prevalence. For example, you are taking a data in the first month and then you wait for 3 months. And whenever the new cases come over the passage of time, so the existing and the new cases, the new and old cases combine together to make a prevalence then. So that is a period prevalence. Very helpful for quantifying disease burden because you know what is the actual prevalence of the disease. So you know the burden, how many people are diseased and how many people are healthy. Relatively easy to estimate because you have to go once and collect the data. There is no need of follow-up visits. Implies a cross-sectional design, and it is a suitable study design to determine the prevalence is a cross-sectional study design. What is the relationship between prevalence and incidence? Prevalence can be viewed as a describing pool of disease in a population. Like this is the prevalence as it is shown over here. Incidence describes the input flow of new cases into. Whenever there are new cases, they are poured into this pool. And if the people die or they migrate, then they are leaving this pool. So the deaths and cover decreases, the prevalence and incidence increases this prevalence. This is another measure of disease frequency incidence. So here incidence cases of AIDS in gay men And from 1980s to 1990s, it decreases. In mid 1980s to 90s, treatment prolonged, so the prevalence increased. These people have not get rid of the disease, and that's why it is increased. Cumulative incidence. Cumulative incidence is just like a proportion because the numerator is taken from the denominator, but the time is mentioned. A specific calendar year is mentioned. Measure the frequency of addition of new cases of disease and is always calculated for a given period of time. For example, annual incidence. Must always state the time period since time is not automatically captured in cumulative incidence. It is not automatically captured, so you have to mention the time. Prevalent cases must be excluded before follow-up. Whenever you determine the incidence in a population, so you have to exclude all the cases because you will not know which case occurred because of the exposure. So you have to exclude all the cases, and then the healthy individual you have to take, and then you have to follow up whether they develop the disease or they do not develop the disease with the passage of time. This is the total number, 1,000 men age 45, and that is the incident 50 developed the prostate cancer, follow-up of 10 years. So now what happened? No one lost to follow-up. The whole sample was followed. No one withdrew from the study. There was no attrition, and cumulative incidence will be equal to 5%. 10-year risk, that is 5% in 10 years. Out of 1,000 people, 50 develop prostate cancer. Most common way to estimate risk, because most common way to estimate the risk, always a proportion. The common way, incidence is the most common way to estimate the risk, whether the risk is associated with the disease or not. Always a proportion, for example, relative risk, always a proportion bounded between 0 and 1, always a fixed or closed cohort. The cumulative incidence is usually calculated or determined in closed cohort, not in open cohort. No exits allowed. Whatever the sample that you have taken, unless in terms of the person died, you cannot allow that person to leave your study. For a brief specification period of time, for example, an outbreak commonly called an attack rate. That is for a very shorter period of time, the incidence. In reality, attrition is a huge problem, loss to follow-up, deaths, and competing risks. Formula does not reflect continually changing population size for dynamic cohorts, open population. Does not allow subjects to be followed for different periods of time. You have to follow all the subjects for a specified period of time, either for 1 year, 2 years, 1 month, 3 months, or 5 years, 10 years. So that is the fixed period of time for all the individual in that sample. In real life, one has to deal with losses, attrition, competing risk, attrition, dynamic cohorts. Dynamic losses may be due to death. Attrition leave the study, and different follow-up time, so rate becomes more relevant. Rate becomes more relevant. Individual may be exposed to, like here, rate may be more relevant than cumulative incidence. The reason is you have to calculate the individual person time, the individual person time in years or in months that he or she spent in a study. So that will become easier for you to add up all the years or months of all the individual intake and put it in the denominator. Individual may be exposed to the risk of an event to varying amounts of time during a total period of time of certain length due to entering the time period later, leaving the time period earlier, experiencing the event of interest. Person time is a calculation combining persons and time, is the sum of the individual units of time that people have been exposed to the risk of an event, is used in the denominator of person time rates, is often used in epidemiology and vital statistics. So person time is a calculation combining persons and time. It is the sum of the individual unit of time that people have been exposed to a risk of an event. Mean the time that each individual spent in a study. Whether the study is of 10 years, but one individual spent a time of 3 years, so you have to take a 3 years time, and the other spent the complete time for 10 years, so you have to take the time of that individual up to 10 years, and you use it in denominator person time. The total time and then used as a denominator is often used in epidemiology and vital statistics. We can use it. So this is basically the incidence rate, where this is the incidence and this is the person time years. All the individual time that you have add up, you have to put over here in the denominator. PTA total time that disease-free individual in the cohort are observed over the study period, total person time experience of the cohort. The synonyms are used for this is hazard rate, incidence density rate, person time incidence, the average person time incidence rate, that is according to the dictionary. Measures the rapidity with which new cases are occurring in a population, most sophisticated form of measuring incidence, most difficult as well. Accounts of losses, competing risks, dynamic turnover, differential follow-up time, changes in exposure over time. And this is the example of incidence rate. Hypothetical cohort of 12 initial disease-free subjects follow over a 5 period of time, from 1990 to 1995. So here you have to calculate the individual time. For example, you have to calculate 1.5 person, 2.5, 3.5, and so on. And then you have to the total time. The total time in the denominator. So here 1.5, 2.5, 3.5, 2.5, all these individual times you have to add up, and that becomes 25 persons years. You have to multiply it with a constant, so 20 new cases per 100 person years, or 200 new cases per 1,000 persons years. What does that mean? It means that when you follow up, when you do a follow-up of 1,000 people, 200 cases will be developed in a year. Study question is the value of 0.20, a proportion. That is a homework or questions for you to answer these questions. So tell me, is the value of 0.20 a proportion? Does the value of 0.20 represent an individual risk of developing disease or what? You have to answer these questions if you know the concepts. Measuring existing cases of a health condition inherently biased towards inclusion of survivors. Prevalence, measuring existing cases of a health conditions. So it is inherently biased towards inclusions of survivors. If you include the survivors, then it becomes inherently biased. The reason is when they have developed the disease, whether the exposure comes first or the disease comes first, what? So primary outcome of a cross-section study, for example, sample survey, 2 types of prevalence, point prevalence and period prevalence. Point prevalence, C, observed cases, and N is the total of the population size at time T, when you visited a population. Measure the frequency of disease at a given point in time. And the prevalence measure the frequency of disease, the burden of disease, the magnitude of the disease, the number of people who have got the disease out of the people, the total population in that community. Point prevalence, suppose there are 150 individuals in the population, and a certain day 15 are ill with the flu. What is the estimated prevalence for this period? So 15 out of 150, that becomes 10%. And the usefulness of prevalence is assessing the health status of a population, whether majority of the people are healthy or they are with the disease. Planning health services, if there are more cases, you have to plan services for them. Often the only measure possible with chronic diseases where incident cases cannot be easily detected. For example, prevalence of hypertension. Chronic disease is, for example, the disease developed over 5 years, 10 years, or the duration is so longer. So when you go, you will identify the people with the chronic diseases easily through prevalence. Not very useful for identifying risk factors. You cannot say that this is the risk factor of this disease because you have not spent time. You just go and you collect the data. So confusion between risk factors for survivors versus risk factor for developing disease makes no sense for conditions that are acute and short duration because they get healthy sooner with short duration. For example, with the flu or any other disease which have a shorter period of time for a person to be recovered. So whenever you go, majority of the people they have got recovered. So it is not very useful, the prevalence then. Period prevalence